because it's fun.
Okay, do we need to have a media? You guys have it like the top. You need to slow down.
First learning addition, subtraction. That was fun.
I'm just waiting to first thing every day and start talking.
Yeah. I think nobody had a good first grade experience. I think fourth grade was and third grade was kind of okay. The other ones.
That's
In my
right.
elementary Oh, see, I didn't learn how to do that until third grade, even though they started teaching in second grade. I didn't get it until third grade. Oh, okay. Wow.
Sorry about that, guys. My phone was ringing.
How long does this one?
That depends on how long it takes them to stop talking.
Hey, show now. Sure.
Wow, okay. Okay, so first we're going to identify what a function is. So a function is something that an input value can be put into that yields some sort of output value. So for example, I don't know, x squared is a function because I can plug in x value in. And then what it equals is my output value. No, well, yes, actually we will. So on a function, one input, x, cannot have more than one output. So if I plug, I don't know, 3 into a function, I can't get 2 answers. That can't work. I can have 2 x's that go to the same answer, y, but I can never have one x that gives me 2 y's. Okay, if that happens, it is not a function. So what we're going to do is we're going to look at some tables of values and use those values to determine whether the relation is a function or not. This is something you should definitely have written down in your notes because it is a wonderful test question. Well, you can do a cheat sheet. Well, you would think, but that's okay. Hey, Grant brought it up, not me. Okay, I'm going to move that to the top, and I'm going to go ahead and write out our first table to consider. So the first thing we're going to consider is this XY table. Just kidding. So my table has the x values -3, -2, -1, and 0. My y values are 5, 7, 9, and 9. The question here, is this a function?
No. Or wait.
Yes, it is. Because what I notice is that each of these x's goes to only one y. In other words, there was no repetition in my x values or in my x column. No pattern here, at least not for this part. So what we look for is that there's no x value that is repeated in my table. If there is, I have an issue if they go to 2 different y values. So let's go ahead and look at another relation to determine whether it is or is not a function. Right, like it couldn't have 2 -3s, it couldn't have 2 -2s, it couldn't have no repetition. So no number can be repeated in that x column. Can't tell. Okay, so the next table we're going to consider is this table. We are looking to determine whether or not this table represents a function. Think to yourself first, and then when you have an answer, raise your hand. The question is this relation a function? Grant, yes or no? How do you know that?
Because -1 goes to 2.
Okay, so my first red flag is that -1 is written on here twice. So when I look at it, I see, as Grant pointed out, that -1 is mapping or related to 2 different outputs. So that means that this is not a function. Anybody confused by how we identified that? Are we okay with that? So of course, we're gonna do one more just as a wonderful little practice, and then we will move on to the next portion. The question is the table relation here a function? When you have an answer, raise your hand. Camden, how did you know it's not? Perfect. The 2 repeats itself, and they map to 2 different y values. This 2 goes to 0, that 2 goes to 1. So not a function. Questions, concerns, or issues with identifying whether a table is a function or not? Yes.
What if it's the 2 in x and they equal to y?
So if both my x's go to the same y,
Yeah.
technically that is still a function because they map to the same thing. But you should never have a repeating point in there. The y is okay. Yes, we can map to the same y as long as one x only goes to one y. Okay. So I don't think we need to do any more examples. Of course, we have them if you want them, but I don't think we need them because that was pretty self-explanatory. So what we're gonna do now is we're gonna look at relations, but they're gonna be set up a little differently, and the question is still gonna be the same. We're still determining whether or not the relation is a function or not. So this time, I'm going to have them set up as a set of points. So my first set of points, I would definitely write these down. I'm gonna go ahead and write 2 of these, just so I don't have to do as much work. So these are the 2 examples we're gonna go ahead and look at. I will wait till everyone is done writing. This is the same thing. Our relation has just been given to us a little differently. That's all. Okay, so looking at that first one, I need to remember what are my x's and what are my y's. So in each coordinate, my first number is always my what? First number is always my x. So in case you can't remember that, it never hurts to go ahead and write x and y above each of the corresponding coordinates in your point. Those x's then are the things that we are looking at. So I need to look at all of my x values and determine if there was any repetition. Was there? No, which automatically means that this relation is a function. So I'm just going to put a check mark because it is. What about this second one? So this green one right here. Hold on. Raise your hand if you think you know. And then I'll look for reasoning. Hannah. How did you know it's not a function? What was your red flag here? Okay, I have a 3 as an x value twice. How did you prove that it's not a function then, Hannah? Each of these 3's maps to a different y. So my first point has 3 mapping to 2. My second one has 3 mapping to -2. 2 and -2 are not the same number, which means one number 3 is mapping to two different y's. So that automatically means that this fails and is not a function. Are we okay with relations given to us as a set of points and determining if it is or is not a function? So then what if our relation has been given to us as a graph? So for example, if I have, a circle, how do I determine whether that is or is not a function? Well, somebody came up with this really cool test called the vertical line test. And it is exactly how it sounds. We draw a vertical line through my graph at any given point. If that vertical line goes through the graph more than one time, it fails my vertical line test and is not a function. I would definitely have vertical line test written down somewhere on your paper. So on this circle, I'm going to go ahead and draw a vertical line, and we're going to see if it passes or fails. Okay, so I drew a vertical line. It's my green one. Did it pass through my graph more than one time? No. So I automatically passed the vertical line test, right? No. We keep testing until all of our lines pass or we get one that fails. So then I go ahead and I draw another one. Oh, let's say right there. Oh.
Wait, do we perform the vertical line just outside of the circle?
Anywhere on this graph. So I drew another vertical line. That's my second green one right here. It touched my graph once. So that means I passed, right? No, we keep going until all of our vertical lines pass or we find one that fails. Am I going to find one that fails here? Yes. If I were to draw a line anywhere inside of the circle, this vertical line touches my graph in two spots. 2 is more than 1, which means it fails. So this one is not a function. Are we okay with that? We do not stop after one line. We do not stop after 4 lines if they all pass. We keep trying until it's obvious that none of them are going to fail. Or we find one that fails and we are done. What's your question, Grant? Well, yes, but that's a little more work. Let's do another one. Let's say I've got, are you talking like you? Okay. So let's say I have a parabola, because we've been doing a lot with parabolas lately. And I want to test to see if this is a function using my vertical line test. So I'm going to grab a vertical line and I'm going to draw it somewhere on this graph. How many times did that vertical line go through my graph? Zilch, which means technically it still passes my vertical line test because it didn't go through more than once. I draw another one. How many times did that one go through my graph? Once. So that one passes. Do I stop now?
No.
No, I keep going. Draw another one. Did that one pass or fail? I'm only hearing like 3 people answer. I really do want to acknowledge that all of you know. Did that one pass or fail?
No.
Pass. It went through my graph one time, right there. What about if I drew one, I don't know, like right here?
I don't know. Pass.
How many times did it go through my graph? So that's the red curve. Once. So that one passed. What about here?
Pass.
Pass.
Do we just figure it out until we get it to fail?
Or until we'll never get one that fails. As I'm looking at this, am I ever going to be able to draw a vertical line that's going to go through this graph more than one time? No. So this one passes. This one is a vertical function because it passes my vertical line test. So sometimes you can just look at it and see, but I still want you to test at least 3 lines. Okay, at least 3 lines for this. Do we have questions, confusions, or anything on my vertical line test? I'm going to have you do one on your own, and then we'll move on to the next piece. So on your own, I would like for you to determine if this graph passes or fails my vertical line test. So if it is or is not a function. Do it on your own. I don't see many of you writing anymore. Are we done already? The solution has been acquired. I like that. Madison, is this going to pass or fail my vertical line test? Fail. How did you know that? Where did you draw your vertical line? So like here, right? Okay. How did that fail my vertical line test? How many times did that vertical line go through my graph? 3. Went through here, here, and here. That is more than once. So I don't have to test anymore because I already found one that failed. So this is not a function because it did not pass my vertical line test. How many of you also got that this was not a function because it failed the test? Is anybody confused by the vertical line test and how we use it? This only works for graphs. Okay, so it only works if I have a graph in front of me. So what we're going to do now is we're going to start looking at domain and range, and then we will be finished. I know you're so excited. So once we have identified whether a function is a function or not, there are specific parts of that function that I'm interested in. The first one is the domain. The domain are all of the x values that I can plug in or the input values, depending on how you wanted to think about that. After the domain, we have the range. The range then are all of the answers or the y values I have, which are also called the output values. So x's are the ones that we plug in. Those are the domain. The answers we get out are our range. So what we're going to do next is we're going to practice finding the domain and range of functions. I know you're so excited. So excited. We're going to start with a set of points because that's just a really easy way to start this. So we're going to start with the function that has the set of points, -1, 3, -2, 4, -3, 5, and -4, 6. And I would like to identify the domain and the range for this function. We're just going to pull numbers directly from here. So since I have specific numbers here, my domain is going to be a set of numbers that will be in curly brackets, and my range will also be a set of numbers that are in curly brackets. So make sure that you have those curly brackets on there. No. My domain are what values? X's. So I go to each of these points, and I find my X values. Those are the first numbers in each coordinate pair. Those numbers are my domain values. So I write them in order from smallest to largest. So my domain are the numbers -1, -2, -3, and -4. That's it for domain. I pulled out all my X's. That's all I had to do. Smallest to largest. Actually, I went opposite. So it doesn't really matter. If my X's were my domain, which ones are my range? The Y's. So I find all of the Y values from these points. So that's going to be 3, 4, 5, and 6. So my domain for this one is a set of my X's, which are -1, -2, -3, and -4. And then the range are my set of Y's, which are 3, 4, 5, and 6. I said smallest to largest, but I'm not going to worry about it because I clearly wrote that one backwards. Questions, concerns, or issues for identifying domain and range from a set of points? Okay. I will say that if we have a number that repeats itself, we only list it once. So, or if a y repeated itself. So if I had -1, 3 and -2, 3, I would only list 3 in here one time. We just don't repeat numbers in our set. Okay? So I'm going to give you one to test on your own, and then we'll move from there. What was your question, Brandon? Well, we're assuming that all of these are functions, so we shouldn't have repeating x's. Repeating y's are okay, but we shouldn't have repeating x's. Okay, so my next function is the set of points -1.5, 3, -1, 2, -0.5, 1, and 0, 3. And I would like for you to identify the domain for this function and the range for this function. Pfeiffer, what are my domain values here? No, 0.5. -0.5.
Oh, okay.
Okay, so what are my domain values? So he just pulled out all the x's from each of these points, and then those were my domain values. Is he correct? Did anybody else get that set of numbers as your domain? Should be yes. Awesome. How about my range, Keith?
1, 2.
So he did 1, 2, and then he recognized that 3 was repeated twice, but I only had to include it once because we don't repeat numbers. So 1, 2, and 3 should be the numbers in your range. They don't have to be in that order. How many of you got those 3 numbers in your range? Do we all feel okay with identifying the domain and range values from a set of numbers? The same would apply if I had a table like we did at the very beginning for our first examples. We just pull the x's and pull the y's, and those are our respective domain and range. So then what if my function was presented to me as a graph, but I was still asked to find my domain and my range? So let's say, for example, or draw this the best we can. I have a function that goes from -2, -2 to, we'll say 3, 3. It's just a nice, pretty straight line. Nope, not where it crosses. Okay, so what we're trying to do is we're trying to find the domain and range for this function, which means I need to figure out the intervals where my graph exists. So we do domain first. So domain is the set of x values for my function. Well, here I don't have just a couple numbers that were plugged in. I have a whole range of numbers. So I need to figure out the smallest number that was plugged in and the largest number that was plugged in, and those are going to be the restrictions for my domain. So I go to the left part of the graph, and I find the leftmost x value that was plugged in. What was that here? -2. So that means my domain starts at -2 goes to x, and then is going to go to some larger value as well. Once I find the leftmost value, I need to find the rightmost value that was plugged into my function. So here, that was what? 3. So my domain goes from -2 to 3. You can write it as an inequality like that, but that's not my favorite. You could also write it like that. -2, 3 with hard brackets, which are the square brackets around it, indicating that I went from x value -3 all the way to x value -2 all the way to x value +3. Either one of those are appropriate for domain. Do we see how we got that range or that interval of values for my domain? We're going to do the same thing for range here, except instead of going from left to right, we're going to go from bottom to top. So x is always in the middle, and we just fill in the left or the bottom point to the top point. Oh, sorry. Oh my gosh. Range y is in the middle because y values are our range values. The farthest points, yes, that's all I care about. These points, it's not always those. It's not always going to work out that it's the end point, I guess is a better thing. So I go bottom to top. What is the lowest y value I had for this function? -2. So that is my left part of the interval. Then I follow it up. What was the highest x value I had for this function? 3. So my range goes from -2 to 3, just like my domain did. Except my domain were x values and my range are y values. Do we kind of see what I'm talking about here? So we're essentially creating the box that encompasses my entire graph. And that's what I've done here. So of course we're going to do another one because this is kind of a little bit of a big thing to wrap your head around. So let's go ahead and do another one. I'm going to go ahead and tell you what the endpoints are because it makes it easier for you to freehand it. Oh, goodness. So the first point we have is -7, 8. And then my rightmost endpoint is going to be 4, -8. Keith, are you drawing this?
No.
You really should be. And then I'm going to do my best to draw the line connecting them. Close enough. So once I have my line and I identify my endpoints because it's a straight line, I'm going to identify the domain and the range for this function. Just like I did before. If you feel comfortable, you're free to work on it on your own. If not, we are going to go through it together. Okay, so we're going to start with domain. Domain moves left to right. So I need to find the leftmost x value that was plugged into my function. Do we know what it is? Yes or no? Yes, what is that x value? -7. Then I need to find my rightmost x value that was plugged into the function. And it was what? 4. So my domain goes from -7 to 4. Are we all okay with that? Then we're gonna go ahead and do our range, which moves from bottom to top. So I find my lowest y value. What value was it at? -8, so that's the bottom. And then I follow it all the way up to my highest y value, which was +8, which means my range goes from -8 to 8. And then we're done. Yes, Emily.
Okay, so I drew my graph weird and it's different numbers. Is that
That's fine. As long as it's true to your graph, I'm okay with it. Questions, concerns, or issues on identifying domain and range from either a set of numbers or from a graph like this? Camden.
So what happens if like there's X prime number, Y with like the same number? Would that just is that not okay? Or
So if I had two different x's that went to the same y,
Yeah.
that's okay.
so would it still be like whatever -8?
Yeah, because it's just a parabola then. Yeah, that's entirely okay. For the test, because this is really new to you, I give you a domain and range problem. It's either going to be a set of numbers or it's going to be a straight line like this one. Because then afterwards, we're going to do more stuff with functions. What? I'd have to look at it. I don't know. Okay, so we're going to do one more thing, and this is by far, in my opinion, the easiest thing on here. And then we are going to be done. Okay? I think it is. Okay, so this one is called evaluating a function in function notation. So we're going to do one example because I think that's going to be enough for you. And then you're free to work on your review. So the function I have for this example is 1/2 x plus 4. And I'm evaluating at two numbers. I'm evaluating x equals 2, and I'm evaluating at x equals -4. Hold on. You've done evaluating before. It just means I'm going to take these x values and I'm going to plug them in. What's new is the function notation portion of this. So I want it written a specific way. So we're going to start with x equals 2. When I plug x equals 2 into this function, I'm replacing all of my x's with 2's, including this one in the parentheses. So function notation says that I am replacing my x's with a certain value, and then I'm also replacing the x's in the function itself with those numbers. So function notation replaces every single x present with a 2, which means my answer is also going to have f of 2 in it instead of f of x. So when I plug this in, I get 1/2 times 2 plus 4. What's 1/2 times 2? 1 plus 4. So function notation answer says that f of 2 equals 5, which means my function solved at 2 equals that number. So that's what I mean by function notation. We're going to do the same thing with x equals -4. Actually, you're going to do it, and then we'll come together and review it as a class. So solve this same function for x equals -4 using function notation. No, I'm changing that x to a -4. I'm putting -4 in for x. Emily, what's -4 times 1/2? So this becomes -2 plus 4, which equals what, Ebony? 2, which means in function notation, f of -4 equals 2, which says that my function solved at -4 equals 2. Are we okay with function notation? Anybody have any major questions, concerns, or issues with anything we've done today with functions? Okay, your review is posted on Canvas. I will post the answer key tomorrow, and I want you to work on it tonight. Sorry. Pull out questions that you're having problems with, and that's what we're going to go over in class tomorrow. Your test is on Thursday. Please do not forget that. So those of you online, your review is posted on Canvas. We're going to go over ones you have issue with tomorrow, and then your test is Thursday. So make sure that this review is turned in by Thursday, because that's when it's due. And tomorrow we're going to make a cheat sheet also. So make sure that you are keeping track of the things that you have issues with, because you'll be able to use the cheat sheet on your test. I would just do one side of an 8.5 by 11 inch sheet paper, yeah.